Let's take a look at a no-volt relay, a faulty one. This is a standard sort of start-stop switch that you might find on a piece of equipment, and in this case, this one was sent by Mike some time ago. I was having a tidy up and found this under the pile, basically speaking. So thank you, Mike, for sending this a very long time ago, not sure when. But this was part of an Audi Ferrex bench sander and sanding wheel, I think. And he said it just stopped working, and he ended up just buying himself a new tool. That stopped working, he ended up just putting a straight on-off switch. Now, the point of these is that, as well as having on-off functionality, it's called a no-volt relay because when the power fails, it will automatically default to off. It's held on magnetically. And the reason for that is that you don't really want equipment suddenly starting up if it can chop your fingers into mince very quickly, as many of these workshop tools can do. Anyway, let's hook it up, and I've got a load. I was looking for something more dignified, but no, it's Christmas lights again. That's just what it is. So as the input side and the output side, you can't really mix them up because if you did that, it would try and energize the coil all the time and make loud buzzing noises probably if you press the stop button, because it would trying to be forcing open the contacts inside. So I'm not sure if is there a sort of live neutral side? This says N, so I'll just make that neutral. So I'll shove that on there. I don't think these are quite the right size of terminals. I won't be fingering round the back anyway while I've got this, and we'll plug it into the Hoppy, well, the Hoppy's little brother, the Anti, with the dimmer display. And since it's flickery and dim, I'll just tell you what it says. So I shall power this up, and nothing should happen. Nothing has happened. No. Let me just zoom out here and bring in the flickery display. When I press this, theoretically it should latch and the light should light. Oh, right, there's the problem. It is not holding on. It's drawing 35 watts, which is way too high for that little coil. I think that coil's got a shorted turning it, and that's why it's not latching on. Okay, that's interesting. Rightio. 35 watts is ridiculously high powered. I would expect this to be something like just 2 or 3 watts. Ah, that explains. It is actually faulty then. Excellent. Let's explore. Let's see if we can find any hint of that inside. So I shall pull all the terminals off. And I shall open this. Now, I can see a little clip here and a clip here. So let's get a screwdriver, a pointy screwdriver, and we'll shove it in there. I shall zoom down a little bit so you can actually see this. So let's see if we can... this might not come out actually, because it looks as though it might just be clipped in rather permanently. That kind of worked. Oh, actually, yes, it did actually work. This as well? Yes. And off it slides. Well, that's jolly good, yes. Now we'll get the front bit off, because that's just on tabs as well, by the look of it. I don't know if I need to take this off, but I'm taking it off. Maybe I'm taking it off. It might not come off easily. It's just as well it didn't latch on then if it's got a faulty coil, because it would have gone up in smoke in due course. It would have overheated. That is not actually coming off terribly easily. What other options do we have here? No, I think I have to take that off. It's not really designed for disassembly and repair. It's very much a throwaway type of item, as many things are these days. There we go. Okay, is this going to yield much? Not sure. Oh, there's screws at the back. Right, well, let's take the screws out. That would be really helpful. Little random driver that might be the right size. It is not the right size. Where's my brass driver? There it is. Is that going to be the right size? Yes, it is. A custom-made driver by Phil, with a Phillips bit in it, strangely enough. So here's what we have inside. We have the coil, and we have these contacts. And to activate this, this is the input, which isn't connected to the coil at all. And when you actually push the start button, it pushes this down, and it doesn't just make the connection through. Oh, that is also very black and sooty, that contact. It's showing signs of wear. But it also energizes the coil, which then holds it in that position. And to turn it off, instead of actually breaking the circuit to the coil, the off button comes down, and it physically pushes the back, and it makes a buzz and opens it up. And as soon as it does open up, it actually breaks the connection, and then it's not energized anymore. Okay, let's see if we can get in further here and see if we can investigate this a little bit more. This coil, is this going to come out? Is there a hidden screw under here? There might be a hidden screw under here, under this label. Let's peel it off. I shall draw you a schematic of this afterwards. Ooh, there's multiple screws. Rightio, let's get multiple screws out then. There's one. Is that going to come out? Nope. There's another. And here's the coil. You can see it is connected to the output contacts here. Let's unwind the coil and see what we can find. This is where, if you're absolutely desperate, you could probably rewind the coil, but it's probably not a good idea. Now, this is a shaded pole electromagnet. And by shaded pole, what I mean is that, see this copper, see how they've cut a slit in the core of the magnet, and then they've put a little bit of brass, copper should I say, around it to form a sort of shunted loop. What that does is, because this is operating AC and passes through the zero crossing point, in the case of the UK 100 times a second, in case of 60 Hz countries 120 times a second, it actually reduces its holding ability, and it makes it noisy and it buzzes a lot. So by putting that little shaded pole here, that little magnetic shunt, it causes a phase shift, and it just rides over that zero crossing point, and it just means it's less buzzy and it's got a greater strength to hold this. But anyway, is that going to come out, or is it punched in? I think it's punched in. It is punched in. Can I get the coil out? The coil is also punched in. Right, tell you what, just give me a second. I'm going to try and liberate this. Maybe I'll just try and liberate it with brute force. I don't think that's going to work. I'm going to have to knock this out in some way, or just grab that pliers. I could I could just keep faffing and get nowhere. Yeah, that's going to happen. So tell you what, I'll pause for a moment and then come back with the schematic, and also once I've opened this. 1 moment, please. Oh, guys, why didn't you tell me I was making a dick of myself? Oh, you were shouting at the screen. Oh, right, okay, you see, this was not dissipating 35 watts of power, which would have been a surprising amount of power for this. It was, in fact, the fairy lights that were drawing the power. What was actually wrong with this device is that the magnetic field just wasn't strong enough to actually counteract the springs. So this assembly, where's the rest of it? There's a little armature that comes down onto the housing, and that is supposed to create a shunt the magnetic field across the coil, and it just wasn't holding. It may just have been not meeting perfectly onto this, or it might just have been the coil was just on the borderline of weakness, that it just didn't quite hold it properly, because they will have skimped every penny they could. But anyway, now we're past my huge monolithic F up. Let's zoom down. Was it repairable? It was one of these things that was on the edge, so to be honest, literally the springiness of the contacts, the little spring at the back, were just too much for it. I don't know if it was that easy to repair. Literally, it was just designed to the edge. But anyway, here is how it works. Here is AC coming in. I'll just draw it as AC instead of marking live and neutral, just in case everybody has different ways. And here are the contacts. The contacts go straight to the out, so that's the in and out, in and out. We don't have that burger chain, I don't think, in the UK. Could be wrong. We've got just about every other one. And then the coil is actually wired across here as well. And it's linked to these switches so that when you actually apply power to it, nothing happens initially, but when you push those contacts closed, and literally the button is literally just pushing these contacts, it's closing them, it then energizes the output, but also energizes the coil that then holds that in position. And then to turn it off, you're just pushing the back here, and it forces the contacts open. As soon as they open the tiniest bit, the coil gets de-energized, and it drops out. It's a very typical mass-produced, cheaply made thing, but that's what it is. But there we have it. So, despite my F-ups, if you enjoy my videos, please consider subscribing. This is something I'm trying at the moment. I've never, right up to like over 1 million subscribers, I never asked people to subscribe. But now it appears that maybe that was the correct thing to do. But it's a bit too late to fix all 2,500 videos now. But there we have it. It's a generic cheap. It is well pitted, so maybe it's just as well it was changed. It looked as though it was on its way out, just because of the wear and tear. I get the feeling it was used quite a lot in the workshop. But there we have it, the no-volt relay. Very simple in operation, very simple, very cheap to make, but a very functional item when it's working.